In this lesson, we're going to talk about systems of inequalities, and our learning target is that we're going to be able to identify a solution set to a system of linear inequalities. So linear inequalities, we talked about systems of equations, and those systems of equations give us just one point. Inequalities, however, will give us a solution set instead of just one point. So we've talked a little bit about inequalities beforehand, but I just want to review a couple of things that we've talked about previously. So first, if we have less thans or greater thans without the equal sign underneath it, we know that's associated with open circles. We kind of talked about in our domain and range lesson. But these are going to go with dotted lines like this. So anytime we see a dotted line, it's going to have a less than or a greater than without the line underneath it. And anything on this dotted line is not considered a part of our solution set. On the other hand, if we have less than or equal to, or greater than or equal to, that goes with closed circles like we talked about in our domain and range lesson. But they also go with solid lines, and any point that's on a solid line is a solution. Okay. The other thing we want to talk about is if we have y is greater than or equal to, we want to shade above the line. Okay, so anything above any equation with y is greater than or equal to, we call all of those solutions. Anything shaded is a solution. And oppositely, if we have y less than or equal to, we want to shade below the line. And those would not be parts of the solution set. So anything that's shaded is a solution. Okay? So let's look at an example. We have y is greater than or equal to x plus 2, and y is less than negative 2x plus 1. So I'm going to graph this first one in red. So remember, y is equal to mx plus b. So this is my slope, and this is my y-intercept. So I'm going to come up to 2 and put my point there. And my slope here is just 1, which means I go up 1 and over 1, up 1 and over 1, like so. And now this is a greater than or equal to, so I'm going to connect these points with a solid line. And now I want to shade, since this is an inequality. So I'm going to shade everything above the line, since this is a greater than symbol. So all of these points are solutions to this first linear inequality. I'll do this next one in yellow now. So this next one starts at 1. That's not a very good color. Let's try pink maybe? Yeah, let's do this in pink. So it starts at 1, and now this time it's going to go, the slope is negative 2. So I'm going to go down 1, 2, and over 1 like this, and I can even go the other way and go up 2 and to the left 1. And since this does not have the line underneath it, I'm going to use dotted lines to represent this. And so now everything is less than, so I'm going to shade everything less than this line, everything below this line, down here. And so all of those are solutions to this line. Now when we're working with linear inequality systems, the solution set is the double shaded region. Okay, it's the double shaded region or double shaded area. So that makes sense. We want to know where both of these are intersecting, right? And we see the red and the pink intersect in this line or this area right here. So we can write all of these solution points, and we can write even a couple non-solution points. So some solutions that I see are points like negative 5, 2, right? And I'll get a black color here. So we could have negative 5, 2 would be like this, and we see that's in the double shaded area. Another point would be negative 6, 4. And so I could go negative 6 and up 4, and that's also in the point. So any 2 points in this entire area would be considered solutions. Now some areas that are not solutions are anywhere else on this graph that's not in here. So we could say a point like 2, 1 is not a solution, right? If we find this on the graph, 2, 1 would be right here. So that's no shade. So that definitely can't be a solution. But even a point like negative 2, negative 4, negative 2, negative 4 would be down here. It's shaded by one of the areas, but in order to be a solution set, it has to be shaded by both. Okay? And now we can use Desmos in order to figure out these solutions. So I'm going to hop over to Desmos and we're going to solve these 2 examples there. So here we are in the SAT graphing calculator in Desmos. So we're going to plug in these 2 examples that we have and figure out what they are. So the first is x plus y is less than 4. And so when I graph it, it tells me what color it is and it's everything below. And we can check this out. We have a dotted line since there's no line underneath my inequality. And we're shading everything below the line. So find your y, and it's a less than, so everything's going to be below. Now I can click this second box here and say y is greater than or equal to 2x minus 2, and I get this nice blue section here. And so now we can just pick any point that's in this double shaded area, right? It's got to be in this area here, not here, not here, not here, because those are only 1 shade max. So any 2 points in here would be fine. So I can find a point like 0, 0, right? And that would be a solution, right? And we can find another point like negative 2, 2. That's also in my area. So this would be a solution here. And now we can find 2 points that is not a solution. So I could say a point like 2, negative 2, and we see that's only in one of the shaded areas. So we'll label this as not a solution. And we can pick one more. I said 4, 7, and we can see that's red way up here. And again, it's not in our double shaded, so that's not a solution, okay? You don't have to pick the same points that I did, but just make sure your 2 solution points are in this double shaded area and your 2 non-solutions are not in that area, okay? So I'm going to clear this all out so we can look at my next example here. I've got 2y plus 2x minus 3 is less than 0. And then my other one is y minus 3x is less than 1. And so we're looking for the double shaded area, which in this case is here. And again, we can find any 2 points. So an easy one to look at is always 0, 0. That is in my solution, or my solution set. So let's call that solution. Another point we could find is 1, negative 2. That one's right there. So we'll label this one as solution. Now let's find 2 non-solutions. So I said negative 1, 1. And again, I'm just coming up, I'm just figuring out any points that are not in that double shaded area. And we could also say a point like 2, 1. It's just in 1, so not a solution for that. So again, any points in this double shaded area are solutions. Any points that are not in that area are not solutions. And this has been our lesson over linear inequalities. Good luck in your practice, and I'll see you in the next video.